Good afternoon, everybody. It's great to be here. I think the audience can do with a little more people in it, but still we'll start off in the interest of time. Thank you, everybody, for being here. Welcome to all of you and the panelists. We have with us a very distinguished set of panelists here. This is an opportunity for all of us to sort of learn from them, from their experience and their vision, as it has been for me. I've been on one or two calls with them. I've been speaking to them on the sidelines, and I think there's a wealth of experience sitting just between the five people seated here. So we have Gilles Garcia, Senior Director from AMD. He's been with AMD since 2016. A wealth of experience again, passed with Xilinx and then IBM. And, especially in the semiconductor industry. Thank you so much for being here. We have Anku Jain from MediaTek. He's the Managing Director at MediaTek. He heads MediaTek's pan-India operations across Noida, Bangalore, and Bombay. He's also responsible for heading multiple R&D business units, an experience spanning of over 25 years, expertise in building business leadership, strategy, and managing cross-cultural teams. Thank you, Anku. Glad to have you here. We also have Rohit Jain, who's the Vice President for Engineering at Airtel. A very accomplished technology professional over a 17-year career. He leads Airtel's IQ and IoT. He's delivered cutting-edge CPaaS solutions for Airtel, transformed customer experiences, and his leadership has ensured a platform reliability of 99.99%. So tremendous, Rohit. Thank you so much for being here. We have Udayan Mukherjee from Intel. He's an Intel Senior Fellow and Chief Architect for the Network and Communications products. Don't know where to start with you, Udayan. He's a 3-time recipient of Intel's Achievement Awards, a dozen patents, multiple patents in the pipeline, associated with 2 startups, a double master's degree, and just thank you so much for being here. Right? Last but not the least, Sumit Goswami, Senior Director with Qualcomm. 25 years of experience in the semiconductor industry, across Qualcomm, across Intel, has designed chips for servers, client compute, integrated graphics, and IoT. Right now, he's responsible for driving the tools, flows, methodology, customer interaction, PMIC, and post-silicon execution at Qualcomm. Right. Great to have you here, Sumit. Thank you so much. I thought we'll start off with a little bit of a background before we hand it over to our panelists. I think what we'll do in this session is have a discussion on the relationships between AI advancements and chipset innovation. What opportunities does it present, especially in terms of the strategic importance it presents for telecom companies. Right? Most of you have heard about AI. Most of you heard about AI chipsets. I think this is an opportunity for us to understand how and what relationship does it have in the telecom space. So I'm going to start off with a very quick question on, how do AI-powered chipsets address the growing complexity in telecom networks, right? And especially what technological limitations they have. So if I can start off with Rohit.
Hello everyone. So I'd like to start with giving you a background about Airtel as a whole, right? So in Airtel, we have around 350 million plus customers. The network that Airtel has, we operate over 220,000 towers. And on daily basis, we process around 112 petabytes of data. Now with that huge customer base and huge network, right, that Airtel has, one big problem that we have is how do we manage and ensure our network is always up, always running. And for this, handling this complexity, we actually need a lot of AI-powered equipments, algorithms to ensure we have predictive maintenance, enhanced monitoring, and we are able to self-correct our network and able to provide a very, very high customer experience. The second one, which is very close to my heart and which is very, very recent, is the real problem that each one of us is facing around the spam and the frauds. And Airtel is able to actually churn really, really big amounts of data. We churn around, I think, 1.3 billion calls a day, and we are able to detect which calls are fraud, which are spam, and we are able to protect our customers from spam. So this is a very, very real use case that we have recently implemented. In terms of limitations, what I feel is that with the growing amount of data and the amount of computation that we need, right? The limitation really comes on how the power of chipsets actually, how amount of data that they actually can basically process on real time basis so that we can do real time decision making. uh, the second, what I think is the quality of data. It is very important, no matter right how big amount of data that you have, unless you have quality of data with you. If the input is not correct, the output will not be correct. So quality, I think, is the second big challenge that we have.
Great. Thanks, Rohit. I'm an Airtel customer and have been for the last 24 years. My spam calls have reduced. I can say that. So thank you so much for doing that, right? And you spoke about limitations. We have three of them sitting right there, and you want to address the limitations, you can always address it. I don't want to make it a customer facing call, but still, Udayan, can I turn to you? Please help Rohit and all of us also reduce some more spam calls.
So, yeah, those are a couple of great use cases that Rohit talked about. And limitations, there are fundamental areas of workload that you got to see. If you're talking about, say, take a wireless network, on the base station side of it, on the packet core side of it, we're also looking into, as we advanced beyond 5G, how some of the AI ML elements can actually improve it, like channel estimation, MIMOs and others. Those are additional use cases. But the thing is that power consumption is critical. Most of these equipments are actually in the far edge. I'll give you an example. An operator recently talked about, hey, I get a lot of data, a lot of logs data, and I need to make some sense out of it. So they got a consultant there and consulted in a very easy way, prescribed GPUs. Great. They then realized that they don't even have a power rail to actually, the footprint is not even there. So they were talking to Intel that time, say, you have a lot of Xeon platforms here. Can you do certain things? Yeah. So I think there are a lot of ways we are addressing it. Some of the inline inferencing, training you will do a couple of times, but inline inferencing, we are adding feature set. We are adding feature set in the code itself. So you are adding, like for example, what do you do in some of the AIML? Underlying is some form of matrix multiplication, accumulation, and MAC kind of functions. So if you can accelerate this thing in a two-dimensional way, so we are doing that in silicon enhancements. So I'll give, this is public knowledge, nothing new. In our Gen 6 products, every code has got an AI acceleration built into it, added to it. So inferencing, you can do this thing. So you don't have to, and whether you have to do training, you can do offline training with GPUs. There are powerful GPUs from many companies, including AMDs and Intels and NVIDIAs. But when you are running a workload like a 5G packet core, or for that matter RAN, the original application you can't forget. That's a latency sensitive application. It's not just you do only parallel. You just don't throw some GPUs into it. So you have to take that into account. So we're enhancing silicon. And if you look into use case on the client side, you will see, and whether it's UEs from Apple or AI PCs from Qualcomm's and Intel's, there are NPUs built into it. An 8-watt form factor wattage, you'll get 140 tops of kind of a AI processing you can build into it. So we are adding those accelerations into the platform. I think both companies are doing it. So these are enhancements that we're doing.
Thanks, Udayan. I'm just going to bring a little more competition into it. So, Gilles, if you could speak from your perspective. And
we are friends.
We are friends.
Great.
And by the way, when you say experienced people, you don't mean old people. Let's be clear.
Absolutely.
So some data will have to be processed at the data center side, and that will be mainly for the GPU. And that's what we are today hearing the most when people are talking about AI with generative AI, open AI into the community. But after that, you can need to process the data on the edge or on the far edge, meaning close to the end users. And so this is where CPUs, by the way, from AMD, Intel, or even ARM from Qualcomm can be a play. But this is also where some dedicated accelerators can be required, because sometimes you will not need even a CPU to process the data, because you will be into a radio, and on the radio you will not put a CPU. You will have an accelerator because you want to do pin cancellation, you want to do spectrum sharing, you want to do spectrum efficiency, power management. So in the sense, at AMD, we have developed a complete set of a portfolio going from GPUs to AI PCs. We are also in this world, and where, in fact, you can really pick the right power, cost, and performance that you need from GPUs with terahops or hundreds of terahops, but also, I would say, power consuming quite a lot. Again, nobody will disagree with that. NVIDIA for sure, they will not disagree with that. And so, but being able to have AI PCs with hundreds of terahops, AI embedded where you will need up to 500 terahops, because you want still to process quite a lot of data. Imagine that you are on the RAN. On the RAN, you have the RIC, the radio intelligent controller. You will have the 3GPP, which is the standard wireless organization. They have made available millions and millions of potential data that you can process. Today, few people are processing it at the RAN level. Most of the data are processed off-sync into the data center or in the edge data center. But if you want to start really playing with your network and have efficient networks, being able to play, then you will need to have those certain amount of data processed at each layer that you required to do some training and most of the time some inference of it. So today, my last word will be limitations. I think that today limitation is probably more the models and the applications than the technology. I believe that this industry on the technology side, we have done some great investments. The technology there, we need to help more our customers, operators first, to understand how they can use and better use the technology which is available.
Thanks, Jim. Thanks so much. I just want to shift a little bit into edge computing and the latency and how AI chipsets address this. So if I can start with you, Anku.
Yeah, first of all, I'm really happy to be on this panel. We have a distinguished panel here, and I'm sure it will be a good discussion. So I'm representing MediaTek. MediaTek is a global fabless semiconductor company, and we are actually powering several verticals like smartphones, smart TVs, routers, speakers, and so on, and having a quite a large market share. And I think one of the big aspects which we keep discussing is AI. I think certainly that is something that's talk of the town. And from our point of view, what we have done is, in fact, last week we launched our latest flagship smartphone chip. It is called MediaTek Dimensity 9400, and that has something called agentic AI inbuilt. So what that does is that not only does it process a certain LLM, but it also take action on based on that. Okay. And I think I would agree with him that going forward, I think chipset evolution is certainly very important. But also, I think evolution of LLMs is also is happening with time. As we go forward, how do we miniaturize the LLM so that it can work on the edge more efficiently? And so edge AI is definitely a way to go. So we had actually demoed recently a model where on the handset itself, one could actually run a stable diffusion model. So you give a prompt, and at runtime you can actually see some images. So and that kind of power is actually available now on the handset. So you can just imagine the amount of power that is. But that's the kind of progression we can see from technology point of view. And I think use cases are developing for sure. And but I think it is both, from the chipset evolution as well as the software side evolution in terms of LLMs and models and training and so on.
Oh, perfect. Yeah. Thanks. Sumit?
Yeah, so actually, if you look at the space, right, I'll just more bring from the chipset point of view, because your question was more towards the chipset, what we are bringing in. If you look at the entire stack, it starts from the thin client capturing data, you send it over a link, and then cloud or edge is processing it. So what you need is that we in Qualcomm believe in like three main things, which is the three main drivers. One definitely is on personalization, like Anku also talked about it. Some of the data definitely I'm not want to send it out to the cloud, so I need to process it right on my device. Second thing is that we talked about the channel part of it, right? Rohit talked about that, the channel estimation use case and the other cases. So 5G, what sort of link level, what sort of AI can come which make my link better and faster and reliable? And the third is that, of course, the edge side, what capability we are bringing in. So these are the three main drivers. So what you look at it here is that we are investing on the foundation level. First, we are investing on the basic IPs, that what sort of different IPs I need in our chipset to bring this capability right on your thin client, like your smartphone, PCs, whatever. Today we are shipping out, like Udayan just mentioned about NPU, the neural processing engine, around 45 TOPS plus, which is capable of take most of the use cases on the device without going to cloud on that. Now, what the help we are getting here is that the personalization and the security. That's a big aspect. You can fine tune your models a lot more personal way rather than giving the generic way. And on top of that, when Gen AI is coming, the number of LLMs, multimodal LLMs coming in, energy is a concern, that also you can reduce. So this is the fundamental investment. We start from the IP level, we generate the chipset, and third interesting thing is the seamless software which can connect all three together. And that's what Qualcomm has invested heavily on software IP generation and this software IP connecting seamlessly. There are a few companies who have solution in all three phases. Qualcomm in on that on the edge side of it, connectivity side of it, and the client side of it. We believe that the future is on the hybrid AI, where the some of the things getting processed in your thin client device, some of the things going over the links going to the cloud. More and more time goes in, you can see a lot of left shift is happening. Right, you can see that around 10 billion parameter model, 10 billion parameter model, you can do it in the airplane mode. You don't need to go into the cloud to do that. If you take a PC, maybe 20 billion, but beyond that, go to 100 billion or so, you need to go to a cloud. More and more advantage coming in is that once we grid this kind of computation in the low power and thermal profile, we can take a lot more left shifting, and that's where the fundamental change is going in. And on the lighter side, great to see that Intel, AMD, both the sides, they are, after the announcement, talking to each other. But guess what? The bigger, more stronger competitor in the middle.
Thanks, Sumit. I think we needed that. After such a deep discussion, we needed that. But I'm just switching a little. I mean, 5G is going to come in very soon. It's going to put a lot more pressure, especially on network efficiency and on user experiences, right? And it's a very high demand environment. So starting off with you, Rohit, how will it optimize network efficiency?
So I like to talk about something called, in Airtel we have something called in-house SOA. SOA stands for self-optimizing network. So this is the technology that Airtel uses to basically ensure our network are always performant. So if you take a real use case, right, networks actually get impacted by customer demand. It gets impacted by day, light, all the natural factors, right, the temperature, etc. And our SOA is able to basically gather data from a lot of sources, from our network usage data, from the satellite imagery, etc. And based on that, it is able to take a decision what parameters to change in the network so that we are able to cater to that upcoming demand on basically time without any human intervention. So this is something that Airtel has usually invested in basically SOAs.
Hold up.
And in terms of customer experience, I also want to talk about Airtel is very heavily investing in ensuring that our customers have best of the customer experience when they contact our customer care center. So be it LLMs, right? Very soon we are doing some POCs around how do we ensure less calls come to an agent and the call gets automatically handled by our in-house voice bot. So these are some technologies that we are already working on. Prior to LLMs coming into the market, right? We were already doing speech analytics. So whatever calls that used to come to our contact center, we used to process these calls for the quality considerations and see whether the call was up to the mark or not, and if there's any kind of personalization that we can do for the customers.
Thanks. You always hear at the beginning of a call that will be recorded for quality purposes. Now you know exactly what happens.
Exactly, this is the quality.
Coming to you, I just want on the user experience part of it for 5G, right? If you could give us some perspective from a MediaTek angle.
So before that, I just want to add one point to what he said. So right now, we also have a lot of conversational AI softwares available. So what that would do is that it can actually decrease the load of the operator because it can act intelligently on who's saying what. And I think a lot of startups from India are doing very, very well. They have actually started in India and now moved to US. So I'm sure that will also play its own game, right? So I think for your question, 5G use cases, that's the question?
Yeah.
So for 5G, I think, last year it was rolled out in the IMC itself in October last year, and now a lot of us are enjoying the 5G speeds. But I think use cases are getting evolved over time. Certainly, the latency and the bandwidth, etc., is helping us. But what I think is over time, the startups which are actually evolving in India and elsewhere, I think those are the people who are creating the use cases which are going to actually take space in the coming years. And similar to when we had the 3G to 4G transition, at that time, Uber couldn't have worked on 3G, but it can work on 4G. Similarly, I think startups are going to exploit the speeds. But coming back to India, I think it is two or three things I can see clearly that India is really a content generation economy, right? A lot of influencers and all that. So those people definitely need a lot of high bandwidth, low latency kind of scenario. So I can see a lot of usage in that sense. In fact, I think the usage is 30 GB per day or something. It's like crazy number, right? So it is. I think the user-generated content, it is a very important use case for this at the moment. But of course, we have upcoming use cases which are happening. But I think this is one which is really caught on. And the second one is for the fixed wireless access. So in the rural areas where the fiber connectivity is difficult, in those cases, the 5G actually the 5G connectivity can actually help for the broadband access for the masses. So
Great.
these two cases.
Thanks. Wait, I have no intentions of doing this, but it's sort of coming to that itself. Before I can ask Rohit to spell out his strategic priorities, I want to give both Gilles and Udayan an opportunity for you to preempt what strategic priorities would somebody like Airtel have, and how can you allow them to drive a competitive advantage in the market, right? So starting off with Gilles and then.
So we are meeting a lot of operators and we are discussing a lot AI with them. Currently, we are seeing them focusing a lot on customer experiences, and so all the calls they are getting and making sure that those calls are going through are answered on time. Security is another key concern. And the third one is cost optimization, because we have all to recognize that the 5G monetization is not as good as it should be in all the sense of the industry. And I think that they are looking at to use AI to have cost-efficient solution, meaning that doing better power management, being able to shut down portion of a radio when the radio is less used than others, having what we call the sleep mode or immediate wake-up call. And so those are, I think, as well, focus that we're getting from the operator saying, okay, I need to cost optimize my networks, how AI can help me. And so that's, I would say, the short term that we are saying. Of course, after that, they are saying, okay, now, how can I deliver new services? By better knowing my end user. So this is where all the new user mobility experience can come with AI, where you are tracking who is where and what and when, and so that you can better deliver the user experience by delivering advertisement that can be paid or delivering new content. So that's, for me, the next level of the operators when they will have covered the first two ones that I explained.
Okay, thanks. Diane?
Yeah, Rohit, for the last 10, 15 years, as you were working on silicon and software for RAN, whether it's a custom RAN that you get from Ericsson's of the world, or Open RAN, or the packet core silicon, as we look into more on the AI side of it, there are three things you should ask. One is the foundation level and the infrastructure level. How can sustainability? How can I reduce my power? So a lot of our silicon and all of our silicon has got power states built into it. Whether it's a frequency that you can lower it, with a sleep state like C state, there are a lot of halts. So if your load line is certain things, but your power is always being used, that's no. So we have traditionally been using this thing in the cloud. Telcos generally wanted to be safe-sided, and even 5-6 years back, they used to turn it off in the BIOS. Now there are more thought process on this, and AI can play a big role into this, tracking the load line. your base stations in the office areas, in the office area in the night times, what are they doing? I mean, they are mostly sleeping. So why is silicon, also not get shut down? And now you have a multi-core platform from all of us. So you can turn on the cores, you can turn on whatever cores you do, you can just keep two for a keep alive kind of a thing. So sustainability at the foundation layer, that's the first thing you should ask. Then as you do 5G, 5G and beyond 6G, there are a lot of chatter, but there is a 6G symposium going on that with NGAs and others, and a lot of people involved. AI native RAN, what does that mean even? So you should ask that my layer one, I do channel estimation, I do MIMO, is AI technologies can do certain things. Doesn't have to be immediately foundation model or Gen AI. Simple things like DQN models or graph neural network, simple elements of it. Can it improve my spectrum efficiency? Can it simplify massive MIMO? And these are what I'm saying to you, these are the stuff that we are working with. We showed a lot of these things with operators in MWC and others, but a lot of other companies are also working on it. So you should ask that elements. Third thing, which I think you alluded to, is the one that you have a lot of data, logs and data. How do I actually do, some of the operators in the US is calling now co-pilot for operations. Feed this thing to not a trillion parameters model, a simple model, and let me query this. They help by radio engineers to debug. The issue right now, that if you take any model like Minstrel or anything, they don't know anything about network. So you strip all of these things, feed the networking data, 3GPP data, ORAN data, spec, performance, and then the logs through rack pipeline and all this, and then actually querying this. So I think these three layers, whether it's foundation layers with power management, sustainability, in the DU, CU, and the algorithms, what can AI do? And the third one is basically whole debugging aspects of it.
Thank you so much for that. And yeah, I'd like to turn to you, Rohit, to see and sort of spell out from your perspective what strategic priorities you have that you'd like AI chipsets to help you out.
Yeah, so I think my colleagues are actually hit the nail on the head, and you are very correct. So very first, I simply say that it's first is cost efficiency. And cost efficiency can be at various levels, as you talked about. It can be at the foundational RAN level, where you have chipsets which are very, very efficient, power efficient. The second, what I talk about, can be usage of AI ops, right? So AI ops can actually help in predictive analysis, getting the data, right? Doing stuff which we right now need human, right? But AI ops can basically automate it, right? A lot of automation we can employ so that the people get best of the experience without any manual intervention. And this can be powered by simple AI. We don't need any generative AI. We don't need any actual. It's the classical AI that we talk about, and just the chipsets can power it. The next thing that I would like to add here is, which gives us a competitive advantage, right? Is basically solutions like I just talked about spam, right? Wherein we look at real data, changing customer behavior, and based on changing customer behavior, we are able to build solutions like spam control. There's another solution that we have created, which is called CDE, Converged Data Engine. And the beauty of that engine is it basically has pipelines from various sources, be it network, be it user, right, be it user behavior events, or the events that happens on the app, or the events or the basically logs that comes on the contact center. We basically bring all the data unified into one single engine and able to generate a lot of insights, and basically are also able to monetize that data pretty well, right? So these are the two competitive advantages and strategic things that Airtel is.
Great, thanks. Hold the thought on cost effectiveness. We'll come back to it. It's a very important topic. But I just wanted to switch to Sumit for him to speak about a little bit of innovations in the AI chipset. You spoke about it a little earlier, but I think just dwell a little more deeper into it and give us some more insights into that.
Yeah, sure. I think Udayan touched upon a few very good points. So the key driver is definitely the power and cost. Basically the TCO, right? The TCO is driving the entire space. And how to optimize TCO? Then of course the real estate lower footprint is required, and second is the power. So now the classic advantage company like Qualcomm have is that we innovated low power for long and we perfected that over years. When I say perfected means you start from the base architecture generation. Second thing is that the IP, and the third is that how the software is kind of scheduling jobs across different cores and optimizing it. All three over the years kind of concurrently developed together. And what we have done is that what we have perfected on a battery powered device, now we are taking it towards the wall powered device. And that's where the strategic advantage is coming on. So like Udan gave an example of when the system is sleeping, how do I switch up the cores different way? This is like we have done many years back on the battery powered devices to get the final nanowatt or the picowatt of the performance from the chip or the power from the chip without compromising anything. We came up with a lot of power states, how to manage it there. And now we are putting the similar kind of architecture and the concepts on the wall powered devices like what the network operators are using. So our point of advantage the key KPI, when we take to that space to the operators, we also talk saying that, hey, I have a more better power device. It's much more lower power because we have perfected the entire stack together. So if you look at the overall, the networking space, Qualcomm have our own solution in both the DU and RU. Now, very specifically, if you come to the RU space, right, that's where not only in the compute side of it, but the RF side of it, that what are the optimizations we are bringing in for the transmissive side of it. And that's where also this RF space we have optimized over the years and the similar concepts coming in on this, right? So these are the fundamental things, like low power is and the cost optimization was in our DNA for long. And that is something we are propagating to this particular space. And it is not like repurposing any chip, but you need to go to the foundation level. All the way starting from even basic things like selecting the transistors for the power sec, selecting the architectural states, how the software scheduler is kind of adjusting between various cores and states, all need to come together to make it happen. And that's exactly precisely we are researching on and putting it into the various products.
Sure, Gilles, you had a point to make.
So all great points, and I completely agree with what you said. I think that we also need to, when we're talking about AI chipset, we need to talk about the software. Meaning, when you have a chipset, you need to be able to configure it, to use it on an optimal fashion. And I think that how you can configure those AI chipsets is critical, what I call the ease of use or the, let's say, the way you can use them. Because the AI chipset can be the best in breed if you don't have the right software for the operators, in our case for the telecom or the scientists or the enterprise to use it, it will be useless. So I think it's critical, and on AMD we are investing drastically on making sure that we have a unified software from GPU to AI PCs, that customers will be able to use the same software to protect their investments on the models, and not only the LLMs, but SLMs now, the short language models. And by the way, your own algorithm that could be different, because we are all working with clever people that will have their own AI algorithm. So I think that you cannot only talk about AI chipset, you need to talk about AI chipset with the software associated. But otherwise, power-wise, I will agree 100% with what you said.
Thanks, Gilles. On the topic of innovations itself, I mean, if you can give us some view from your perspective of how this is driving, whether it's on the telecom network space or whether it's on the user experience status.
So I think I would like to agree with the software part. You know, if you see the smartphone chipset itself, from what MediaTek has done is it actually exposed the AI APIs to the app development community. So the real innovations or real use cases actually will come from there. Mm-hmm. And how do we expose the AI capability to the app development community is very, very important. So that's one thing we have done, and I think I totally agree that software would play a big role in order to exploit this overall ecosystem of AI chipsets. So that is one thing. And the other question you had about
just innovations in chipsets. How is it going to help from a MediaTek
so innovation, one innovation which is I think common for all the chipset players is about what nodes are you using to design the chipset. Okay. So the latest chipset we have is built on 3 nanometer process. Mm-hmm. Now that itself brings its own sets of power efficiencies and computing power. I think that innovation will still continue, but there's a lot of innovation on 3D packaging and all that, which will also, kind of push this chipset going better, become better. A lot of innovation on those sides, and And if you talk about 5G, then of course we are also working on 6G, which is still long way away. I think we'll see 6G by end of this decade, hopefully. MediaTek is already working on the 6G white paper. I mean, it had released the 6G white paper last year, and also we are part of the standardization committees for 6G. So that is something which is going forward. But right now, I think a lot of chipset activities happening for the power efficiency and speed.
Great,
Yeah.
thanks. I just want to shift gears a little bit. I mean, this is something that I think anybody in India, or even especially the government, loves to hear, especially from people like you on the manufacturing of chipsets, right? Manufacturing of AI chipsets, especially. We love this term called leapfrog. Everybody talks about how India moved from skip the whole landline revolution, moved to mobile phones directly, right? I think everybody in India, and especially the government, wants to see us leapfrog every single revolution and move on to the next one. I know I've been in this space also for a long time, so I know it's really difficult. But I mean, it'll be interesting to hear from all of you on how you see manufacturing of AI chipsets. Will it ever happen in India? Right? We've taken baby steps now in terms of semiconductor manufacturing, in terms of ATMPs and OSATs. Will that ever happen sometime in the future? Could be 10 years from now, doesn't matter. But also, where is India today in that space? How long will it take? And sort of what needs to be done for that? If I could start with you, Dayan.
Yeah, every operator that we work with, the first thing they say made in India, whether it's a platform, whether it's a software, but I think the this thing element is the silicon side of it, chipset. So what is happening here is right now, because of talent, because of cost, because of a lot of this direction, we are moving a lot of our chipset designs. We talked about packaging. There are a lot of innovations. By the way, innovations you're talking about process as well as in packaging. You don't have to have the latest and greatest process in all the chipset. It's a multi-chip kind of environment. So a lot of those things are happening there. But we have moved a lot of those designs. Some of the things that AIPC stuff that we are designing, a lot of the server side, that the stuff that we're doing in Xeon 6, and a lot of designs happen in Bangalore. So my design teams are here, my silicon team is there. Now the next thing is when is basically we will have a manufacturing of the fabs. If you're really getting that, it's going to happen. It's already green shoots are there. It's happening. It will take, because that's a billions and billions of dollars of investment. Ask Intel. We know. I mean, the kind of money that we're spending in Ohio and stuff like this, driving us crazy. So those kind of things needs to be, a lot of, and then the government incentives also comes a big play. I think India government is now gearing up for that. So I think policies are getting set up. I see it will start with many times in the packaging side of it. You have those chipsets coming from Intel, coming from TSMC. It doesn't have to be from one supplier. So you can actually integrate and package it together. That can happen. That can happen in, I say 5-6 years. It can happen. And then you get to the fab, which is the last nirvana. But I think it's just a matter of time. Talent, economic, everything is best. Customer set is here. Next generation customers are all here. Rohit, I mean, this is, Oda and anything. That's kind of a scale that India can provide. Nowhere else it can happen. So if the customers are there, then product has to be built here.
Absolutely. Fingers crossed. I know this is, in my short career, this is the third time I'm be stepping into the semiconductor manufacturing space. And I believe third time lucky. Let's hope we do that. Yeah. Sure. Good.
So actually, I was in the Semicon event last month in Greater Noida, and there was a roundtable with Minister Ashwini Vaishnav and global CEOs from all parts of the world. And I think someone commented that this is the first time they're seeing all the ecosystem players under the same roof. For example, Fabless of course was there, but also the foundry people, the testing people, the chemicals and the gases. And I think there's some kind of FOMO factor. I think people, from the globally, the companies, they actually think that if they miss out, then they will lose something, because even the competition is there. I remember one specific sector, both the competitors were talking to each other. you're here, so because I'm here. So, so I think that FOMO factor is happening. So I think the ecosystem is actually building up, momentum is catching on. But of course, the fab would be still at the legacy node at the moment, like 20 nanometers and above. And slowly and surely, I think it'll move up the value chain. AI chipsets, I think it's a bit long way to go because those require certainly better nodes. But I think momentum, the third time, as you said, I think this time it will happen.
Absolutely.
that's what
So I would actually like to dissect this problem into two different things.
Sure,
Right?
please go ahead.
So anytime, right, this can only happen by the three things: government policies, some of the MNCs and startups are coming, innovating on the space, and third is the manufacturing. If you take that the first thing, government, right, all of us in the panel, we discussed that the government right intention is very much visible, right? They're promoting on that. If you look at the companies, right, all of us have a very big R&D centers in India. So a lot of the chip design today, all the AI chip design is happening over here. Algorithms are getting evolved, software stack is getting created, silicon design is happening on the latest and greatest nodes. So there is no problem on the talent. Qualcomm, we run a program called Qualcomm Semiconductor Mentorship Program, QSMP. It's in collaboration with Government of India. We get proposals from various startups, and I am blown away by seeing that the amount of innovation they are doing in the design space. If you look at the companies listed in DLI today, many of them are the AI companies. So these two factors are already comprehended. All big companies, MNCs, they are supporting the small companies. I'm sure everybody have an incubation program. All of them are supporting the small companies. And small companies are coming up with idea. Now the manufacturing, right? Manufacturing is a separate dynamics altogether. It's a complicated supply chain and it will need to naturally evolve. It cannot come tomorrow and then immediately everybody dump their chipset over there and chips getting produced and let's say consumer like Rohit buying it and doing it. It will take its own cycle and we need to allow that. Does it mean that we are lagging something on that? I feel it is not. I agree with the FOMO factor, what Anku was talking about. If you look at any particular chip when you buy, or let's say Airtel buying or anybody buying, it is not because of which tech node it is manufactured. It is the functionality it is providing. And those functionalities are coded today over here. It may be manufactured, may not be manufactured over here. Over the period of time, that definitely going to happen. But not maybe in the near future, but definitely one day it's going to come up.
Okay, thanks. Gilles has something to add to it.
So a quick one. I'm a French guy, so I'm not from India, as you can see. And I have doubt. So let me put that I have doubt that AI chipset manufacturing will be sometimes in India. The key reason is I believe on the talent and the fact that India will have manufacturing. What I think that when you are moving into a manufacturing play, the investment, the sustainable investment that you need to do, because it's not a one point in time, is huge. And again, I think that my colleague will probably agree with that. So if this is to get into the manufacturing and not being able after that to continue the investment to always get the leading edge, that's probably not to happen. What India will have to take is probably to pick the game. Where does India want to invest on the manufacturing side? Is it more on the cheap consumer? Is it more on something else from the semiconductor? Because I'm convinced that this can happen. But the AI chipset, which is probably always at the leading edge technology, could be a difficulty. And the worst things that you can have is an empty fab. Because then each chipset which is getting out of this fab need to bear the cost of the complete fab. And so that's something which is very important, is making sure that suddenly India is just not building manufacturing capabilities that will not be able to be filled.
I mean, you're being extremely practical. I'd always like to be optimistic. So let's hope that we have something going on. Just want to shift again a little bit in terms of, you all spoke about cost effectiveness, especially in deployment, right? And I think we've heard of, Blackwell getting into insane amounts of orders, and the market says that it's going to drive a lot of billions of dollars of revenues especially for NVIDIA. But it also means one thing: if billions of dollars of revenue for NVIDIA means it's coming from somebody's pocket, right? Which means that the deployment costs are extremely high, and that's where the money is going to come from. So, Rohit, I just want to touch upon you so that you can speak a little bit of cost effectiveness in deployment and sort of set the stage for that. And then we'll go into the rest of them to see of how they're actually tackling that particular problem.
So I think as a company being on the consumer side, we are actually facing huge issues, supply side issues in terms of availability of chipsets, right? How Airtel is tackling, right? I can talk about that. The first thing that we are doing is in terms of ensuring whatever AI algorithms that we have, they are very optimized, right? So we have recently did some partnership with NVIDIA, etc., and they helped us optimizing our speech analytics system to by 3x. So that means we need 3x less resources, right, in terms of doing the same thing. The second thing that we are doing is, see, in cloud you get pay as you go model, right? So wherever we can build solution on cloud or use cloud or leverage our partnership with companies like Google, etc., right? We are going ahead with that. So these are the two things that we are majorly basically ensuring how we make sure we are cost effective.
Sure. Udayan, would you want to take that topic on to see how you can reduce the cost effectiveness?
Just to comment on your billions of dollars in Blackwell, there are two set of areas that money is being spent. One is on the cloud guys, fear of missing out, build more and more, and let's buy all these GPUs. We'll figure out what we'll do. And then some of the sovereign countries like Saudi Arabia and other countries. We cater to telcos. They're cash strapped. You ask Vodafone, you ask Verizon, AT&Ts. By the way, every Open RAN or vRAN that we deploy is all running in Intel silicon. Not a single one yet, And the same thing, x86 can be AMD as well. But every one of this, the first and foremost, you can talk about AIPC, Fuchsia, layer 1, layer 2, but this is all about TCO. Total cost of ownership, then it becomes cutthroat on these things. So you have to address that aspect first. If I'm addressing virtual RAN or packet core or OSS, BSS, and I say, okay, I'm giving you huge amount of AI capabilities right now, but it'll cost you money. No, they're not going to get it right now. In fact, they will ask me, every operator asking me, tell me what kind of use case I can run on this right now. So I think it has to be very competitive. Enterprise and telcos and enterprise are asking right questions on TCO. What use cases are really you're doing? And then what we are doing, and I think it's a similar strategy also there with our friends in Qualcomm and others, that we are building those targeted accelerations. We are augmenting it into CPUs. We are adding, there are discrete GPU cards as well from all our companies. So if you need that, we add these things, but you don't have to spend billions of dollars with an LLM in every bit of it for most of these workloads. So that's the, at this point, strategy. Data center is a different strategy, so which we are not going to touch at this point here.
Absolutely not. But Sumit, I'll just come in order itself. If you can speak a little bit about how to drive cost effectiveness in this particular space.
No, this, like Udayan mentioned and Rohit mentioned, if you look at this particular space, it is all about TCO and scalability. These two things kind of drive this industry, right? So, as I said before, right, I mean, the total cost optimization is part of our DNA all the way starting from the chip design, right? And I'm sure that it is not specific to Qualcomm, all the other companies, that is the key focus on that. And the first thing is that you look at the entire stack and see that where I can optimize the most. All the way, the total WAN network, like C-WAN, V-WAN, O-WAN, whatever, right? What are the equipments we are using? So number one factor what we look at is that how do I reduce the ASP of a particular chip? Mm-hmm. Second thing what we look at is that at the platform level, it is not like a single chip going in, there are a lot of auxiliary chip coming over there. So what is the total EBOM optimization we look at the platform? So these two are the primary. If you look at the mindset some years back, that ASP control is my game, and maybe some of the system integrators, they will think about the EBOM and the rest of the solution. So now EBOM is very much into our game, saying that how much I can optimize the overall platform cost, not exactly my chip cost on that. Like there are a lot of small components from all the way up to the antenna. Can I just optimize the counts on that? Can I optimize the cost of that? And third is that the overall software cost. It should not be totally different things I'm making, that the software investment need to be so large that NRE kills me. So we look at all the three factors very cautiously at the time of the program planning, and then we come up with a solution on that. So if I say that what KPI is driving here, this is the prime KPI driving for us. All of us are looking at optimizing that.
Great. G?
So you started the discussion about the cost of the GPUs. And so one way we are seeing the cost of GPU going down is competition. So if there is only single guy in town, then suddenly that's not making up, because then he will be able to make you paying whatever you want. So I'm really encouraging the people to look at the AMD GPUs, to test it, and then that will help to reduce the cost. So that's one. But the other point is, back to you, is architecture is really making the difference. We are talking about GPUs and the comment that only the hyperscalers are really going into it. That's a fact, because they have a huge amount of data to process for their search, mainly today for their search, for all the LLMs that they are processing. But back to the telecom is, where do you want to process your data, and which type of data do you want to process, and for which application? And I think that for the time being, back to the beginning, is what are the drivers from an application perspective, beside cost optimization for the networks and everything? What are the drivers from an application perspective that will help the operator to monetize the AI as well?
Thanks. Conscious of time, I want to leave some time for audience questions also, if it's possible for that. But I think there's one very critical topic that I'd like to address in our discussion. I mean, this is on security, right? And I think it's the single most thing that keeps everybody awake at night. Right from, I don't know how you can actually address it, but as a user, from a user's perspective, I think the latest thing that's been doing the round is called the FedEx scam, right? Where somebody gives you a call and says that there's a package waiting for you, can you give me your this one? And I'm not sure if it can actually address it, but I think security has become the single most important aspect that even for CTOs and for users that are important. So I just want each of you to sort of spend a few minutes talking about security, and I want to get everybody's perspective on this, so that we have all of you chiming in and talking about.
So I think I feel in general security, of course, is a technology play. One has to build up systems in chipsets and software to kind of handle that. But I think more important than that, I think it's a regulation play. I think the government has to play a big role in regulating and maybe punishing people who are creating such nuisance values. Like the example you gave, if someone is able to figure out how it happened, then what do they do about it? I think that kind of fear factor has to be there in those people. So I think that could also play a big role. Regulation itself. But of course, technology-wise, I think all of us are working very hard to ensure the security aspect which is taken care of. Yeah.
Great, yeah. But I think one is government regulation, second is operators, and then we'll go on to the chipsets part to see how we can actually do it. So
in terms of security, I think there's a famous saying that no matter how much you do in security, it is never enough, right? So in Airtel, there are two types of security that we are primarily concerned with. One is our network security, right? So Airtel being operated in basically the entire India, we have a very large footprint, right? So we basically deploy best of the technology to ensure we have very good quality intrusion detection and prevention system. All the network access controls are have a very good system, all AI controlled, etc. To ensure that our system, because Airtel can be very, very vulnerable to all the DDoS attacks, right? All the very sophisticated attacks that can happen on our network. So this security is very, 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 very important. The second type of security that we are very concerned with is our consumer security, right? The one we already launched a product which we call spam-free network, right? Wherein we detect calls, we detect patterns, right? So let's say if someone is fraudster, right? There is very likelihood that the SIM will be changed very, very frequently. The device will be changed, and all this data is actually as an operator, it's our responsibility that we use this data very rightly and basically able to prevent these scams, right? So one is we are building products for basically our consumers to prevent all kinds of fraud. The second thing is we have this data which is very, very useful for a lot of financial companies. For example, let's say if we have some data in terms of about the location of the customer or amount of time the customer has changed his SIM, etc. All the amount of calls the call is being made from the SIM in a day, right? So in totality, this data can be very, very useful in terms of detecting whether the financial transaction that is about to happen is a fraudulent transaction or not. Maybe there is some kind of probability by which you can tell, yes, 90% it looks not fraud, and in some case you can tell, yes, it looks fraud, right? With the help of this telco data that we set on. So
Wait, now that Rohit set the stage of what he expects, let's hear from Jean.
So let's see if we can meet the expectation. So again, we are talking about AI. So first of all, AI is a great way to help on the security. So we have already demonstrated DDoS capabilities with ML algorithm. But for me, as a chipset vendor, the first things we are doing, we are making sure that our chips are secure themselves, because a lot of data are going through the chip. So we need to make sure that the chips are secure. And by the way, whatever it is, a chip for the laptop or a CPU or a GPU or AI embedded, we need to have this security hardened into the chipset. But two, you cannot compare a CPU doing a software, for example, for the baseband that will have 100 gigabit of data coming to it, to an optical platforms that will have to deal with terabits of data. So same thing, the security need to be at each layer of the networks. From the cell phone, and I'm sure that you will talk about it, to the radio, to the CPUs, but to the IP platforms, to the optical platform, and even to the data center and the software applications as well. So we can talk a lot about security, but definitely on the AI chipset, the chipset AI can be a very good help and very good fit for the security aspect in order to help the operators on that.
Yeah, let me start by saying that, yeah, we are meeting his expectation already. So
Thank you.
So we start with a very basic research level, right? We are kind of involved with multiple educational institutes across the globe on the security research, the very fundamental security research. So we have a dedicated hardware security blocks, which is authenticating all the transactions inside. Take an example. We know that Intel out-of-order execution engine, like it's a robust and solid engine for years, but Spectre meltdown came. And as Rohit was saying, it is not good enough, right? I think it's always some hacker will be there, they are innovative, they will figure out a way. So what we do is that the fundamental research level, how we can enhance it. For example, like physically unclonable function is a very popular topic. We look at it very carefully, work with various universities to get it up. Every secure transaction, software layer, everywhere we are very much focused on that. On top of that, as a paranoia, we involve with the third-party audit companies to ensure that it is indeed secure. In the entire stack, starting from cell phone all the way to RAN and the cloud point of view, entire transaction, everything is secured. So we run a lot of this kind of security audits to ensure that it is there. And lastly, I would say that, I mean, there is a lot of cybersecurity standards need to come out. Like we know that European Union already employing quite a lot over that. More and more we kind of set those standards and keep on, like India government also started putting on the various sectors on the various security standards. Standards are evolving over a period of time. I take this more as a collective industry-wide problem which industry need to join hand to solve that. It is not like an individual, one company can solve the entire problem. All of us need to join hand. And today, actually, all of us are doing that. There are various agencies, security agencies, where all come together and figure out what is the next step of a certain protocol should go, which will make it a lot more safe and secure. And that's how we are solving it.
Absolutely right. Udayan, can I get some?
Yeah, I agree that it takes a village. You know, you talked about some of the elements of out of order. I mean, this is our close collaboration with companies like Google that we jointly worked on fixing this. And the other thing is how quickly you respond to it. You know, because how much you do, you know, I mean, there is always going to be bad actors trying to exploit stuff. But if you look at the security, it's a holistic hardware software. What we do in the platform is start from the very foundation of, you know, the boot side of it. Is you have a trusted boot. And then you have a trusted execution, secure enclave. Sometimes we don't trust software, so it has to be purely on hardware. You separate some cores, which is purely, you can do some of these elements like if you're generating keys, for IP sake, you can do this thing in a secure way that nobody even look into it and get into it. Communications, I think you talked about this thing. So IPsec stuff, the ODAN Alliance talks about MACsec now in layer one to actually come, over the air as well to actually provide security. So every aspect of this thing has to be looked at. Silicon plays a key role into these things, but software and elements. And in Intel, we also have a lot of engagement going on among our companies as well as with universities and cloud providers to actually help us. It's not a one company's job. Together, if there's any iota of, we even had those kind of things, break it open, try to break it so that we have those kind of always that hackathon going on. We will give you money if you try to break this thing. So this kind of things always helps. There's always going to be creative way people come out of it, some of this stuff.
Thank you so much, everybody. Just want to turn to the audience to see if you have any questions for this.
My name is Srini Kopparapu,
Okay.
and I'm from Hyderabad, so I'm a CTO for multiple SaaS product companies and everything. The question goes to everybody. So because I got a surprise from one of the customer, we recently did an RFP proposal for an airline industry, and we proposed an AML solution with LLM model and all other things. Immediately, the storylines worked very well from the top down, and everybody was happy because they are saving dollars, they're saving the cost per year and all other things. Then the other side of the world also raised one question. You said you're going to do with LLM solution and everything. And as an airline industry, we are already buying some carbon credits. Now you are asking me to buy more credits. So that's a boomerang question. I got a 30 seconds pass. I figured out how to come out of it, but I don't have an answer for now.
I can start with it. So initially, in the Gen AI timeframe, the number of prompts multiplied by the number of users requires huge amount of energy to run workloads on the cloud. So what we are trying to solve it here is that doing a lot more ref shifting on your devices so that you don't need to really go back and burn the energy to generate those AI/ML performance. So this is our way of solving it. As I was saying that today we can do up to certain extent, and I can see that more day progresses, algorithms are improving, software is improving, silicon is improving. You can see more and more things you can do it over there. Can I do all the workload processing in my local device without going to cloud and burning more energy? May not be possible now because use case is also evolving. But that ref shifting is the game. Everybody, we are trying out to make it happen.
Thanks. Thank you.
My name is Manoj. I am from Voxmas. So earlier we used to have multiple mobile charger pin provided by different kind of phone manufacturers, right? And life was complex. And then the mini USB or USB charger came and the life became simpler, right? Similarly, just want to understand, since you are different kind of GPU chipset providers, is there going to be a middleware similar to CUDA so that the high-level programmer, they can just start working without thinking about GPUs?
So, great question. I love it. The strategy that AMD is doing is to go to open source. Because I think that AI will definitely look for non-proprietary implementation. And so we have opened all our software to the open source so that the community can add to it in order to make sure that the models that will be run can be ported with the same software, open source all the way through, depending where you want to do. So be careful. It's a journey. So I want to make sure that we are not all jumping through the hoops. This is definitely a journey. We have today open source software that can run for the GPU. We are moving to the CPU, and the next will be the AI embedded. So, but definitely, the goal is to, I'm not sure that we'll be able to have one software that will do NVIDIA, Intel, and AMD GPUs. I'm not expecting that. But the strategy we are taking is going to the open source so that people can control their destiny. Because I think that was important for operators and even for the hyperscalers. They want to control themselves. They don't want to be in the hands of somebody.
Thanks, Sheil. Just one last question. We have to move on. The next panel is waiting for us. Does anybody?
Hi, I'm Arjuman and I run an AI company for data labeling and data training. My key question is with respect to the Indian landscape. Where do you see India adding value in the whole supply chain of components with respect to the infrastructure of computers and computing, considering we are having a big push towards semiconductors and conductors and chips? So where does India stand in that purview? Would like to understand your perspective on that.
If you're asking where India stands, I mean, let's look into from the silicon side of it. And then you are in that industry, so the software and model, I'm assuming you are already developing it. Lot of the designing, as we talked about our targeted accelerations that we are doing, we are integrating in the chipset to lower the power. Lot of designs. There's an old article from actually Google. If you Google that in ACM, you'll find it that they were doing the original accelerators for TensorFlow, some of the aspects. Things need to change because some of this foundation model and the AI aspects has brought in new model. So acceleration has to change. So a lot of configurable accelerations that we are designing is happening here in India. You know, the design aspects of it. And then it's manufactured and getting integrated. So there is already, you know, value-added aspects happening here. And the model, we talked about the shortcomings in models, you know. Again, a lot of those softer aspects of it. Who else can develop this thing? But you know, the talent is here. And I think all through the value chain, you can add a lot of values here.
Thank you, Dan. I think we're at the end of the hour. Thank you so much for everybody for being here, listening to them. I wish we had more time to have an interactive session, but we'll have to close it here. Thank you, everybody. Udayan, Sumit, Gilles, Rohit, Anku. Lovely being a part of this, learning from you, of course. And yeah, we'd like to see, I think next year, to see what actually happens. And it'll be good to have a part 2 of this whole conversation there. But thank you so much for being here. Thank you for your time.